But one quick thing I would like to point out is that internet is bad. So we might be going off and on, but just stick around and watch up to the end, okay? So we've got these four questions. The first question, they're saying y is equal to x power 3 minus 5, x power 2 plus 8x minus 4 at x is equal to 1. I hope you can see that. So that's the first question. We need now to find the equation tangent to the curve, okay? Hi, could you tell me if it's clear where you are watching this live broadcast from? Is it clear so that we can do these questions together? Remember, we're chasing internet. Internet is really bad. It's really bad, but we'll try to do our best. So share the video. Let me get to have more people watching this. Here we're saying simplify. We must put a Y here. Simplify. Watching from KP. Thank you so much, Henry. Danny, it's clear. Thank you. So, guys, the first question here, we're trying to find the equation tangent to this curve. And normally, what we first do is to just get the given equation. This is calculus. So when you're given something like this, just get the given equation and then find its dy dx. That's a derivative. So when we say dy dx, we're simply talking about the derivative. So dy dx is equal to, there is a 1 here. So you get the power multiplied by the number in front. So 3 times 1, it's a 3. You write x, here power 2. Because after multiplying, you subtract a 1 from the power. Here it will be 10x power 1 plus 8. So that's it. That's a derivative of that function or equation right over there. So is it okay up to there? How I've found the dy dx? Are you okay with it? Watching from Lusaka. Thank you so much. It's clear. It's clear, right? Up to here. Are you okay with it? I know we've been doing this very much, and most of you know how to find the dy dx. Quickly say if it's clear so that we can make it so that we can make a move. We need to finish these questions as soon as possible before we start facing internet issues. All right, so if at all it's clear, so now once you get to find this dy dx, you now say m is equal to, this is a gradient. This is a gradient function now, the actual gradient. We do not gradient using letter m. We're now going to use the x value, which is a 1. Wherever there is x, we put a 1. And this is how it's coming out. So this is a 3 minus 10 plus 8. So 3 plus 8 is giving us 11 minus 1. And this is a 1. So the m, which is a gradient, is the 1 which we found right there. So that's 1 as our m. So now, guys, from here, we now need to actually find now the y coordinate. We've got the x coordinate here. Look at this. We can now say our m is equal to 1. We just found the gradient to be equal to 1. Now to find the y value, you use the actual given equation, and where there is x, without finding dy dx, we substitute, because we want now to find the coordinates. We know that the x value is a 1, the y value we don't know. So get this x value, put it where x is, so that we can find the y value. This is calculus, guys. In case you don't know, this is calculus exam question. And when you simplify here, we are going to get something like this. Y is equal to this, and this is giving us a 9. 9 minus this and this, 9, which is a 0. So the y coordinate is a 0 there. Okay, it is a 0. So now after getting this 0, we now say y minus y2 is equal to m x minus x1. I guess you know this equation or formula. It's a formula for finding equation of a straight line. So we now plug in, we know that this is our x1, y1. So y minus 0 is equal to m is the 1, x minus 1. Y is equal to 1, x, which is just x minus 1. So this is the equation tangent to the curve, this curve. At that point, x is equal to a 1. I guess it's clear now. I guess it's clear right about now. It's clear, right? Yeah, I can see people saying it's clear, which is good. So we now go to the next question. The next question is a quadratic equation. We need to solve this. So if you've never solved a quadratic equation using completing the square method, check out this. So it's supposed to be a 2x power 2 is equal to 7 minus 10. So we're going to complete the square. So for completing the square method, you maintain this term the way it is, and then a 10 minus 10 will come this side, it will be plus 10. We've got a 7 there, okay? We divide throughout by 2. The reason why we are dividing, we want to have a 1 here as a coefficient, a 1. So, like that. Okay? So have you seen the way it looks? So once you do that, once you do this, are you guys following? Are you guys following here? So once you do this, I'm worried of the internet, so I don't know if you guys are following. So if you're not participating in, I won't be able to know if really somebody's following. All right, so once you do this, you are now going to pick the number which is here, the coefficient, that's a 5. So when you pick that 5, it's a 5. I want to show you something. This is a procedure. So when you pick that 5, I wanted to use different color. Now it's not working. So when you pick this 5, you divide it by 2. Always, whatever number is here, divide it by 2, and then square. You're getting a 25 over 4. So this 25 over 4 should be added to both sides of the equation. So we say plus 25 over 4 equal to 7 over 2 plus 25 over 4. I guess you've seen this 25, you added this side of the equation and the other side, and this is what I've done. Okay. So now from this point, you are simply going to write the perfect square. So after doing this, you now get the x, just x without a power 2. And then you say, since there is plus here, you say plus what is here? Plus 5 over 2. And then you put a power 2 here. So this is a perfect square, such that when we simplify, it will take us back to this. Okay? It's equal to, here, 4 is the lowest common denominator. So 2 into 4, it's a 4. 4 times 7, it's a 14, plus 25 there. Okay? And from here, you can say x plus 5 over 2 power 2 is equal to 39 over 4. So now to solve for x, you get rid of this power 2 by introducing the square root, both sides. So this is x plus 5 over 2 is equal to square root of 39, that's positive over negative, over a 2, because square root of 4 is a 2. So the answers, x is equal to square root over 39 over 2 minus 5 over 2, which is just a square root of 39 minus 5 over 2. This is one of the solutions for the quadratic equation. So if you want, you can use a calculator to simplify this. It will give you the number in decimal form. The other one will be negative square root of 39 over 2 minus 5 over 2, which is equal to negative square root of 39 minus 5 over a 2. That's another solution. So that's how it's done for that one. So let's try now to simplify this. So simplifying that one, that would definitely be, it will be 9a minus c over 81a squared minus c squared. So here we can use difference of two squares down here. So this will be a 9 power 2, a power 2 minus c power 2. So if you don't know difference of two squares, the moment you see the power 2's, you now copy what is on top, copy what is down here. This is difference of two squares, such that this and this is a 1. Our answer will be 1 over 9a plus c, like that. Okay. So now we go to the last question. So the last question, I will do this for you. So this is 10 tan theta is equal to 50. So divide by 10, this and this will go. Tan theta is equal to 5. So say theta is equal to tan inverse of 5. So when you punch on your calculator, I think it's going to give you 70 something, 78? Yeah, something when you punch on your calculator, this one. That's the answer, because the range here is from 0 to 90. So it's only one solution for this question. Thank you so much, guys. Thank you so much, guys. So explain for me slowly on question 4. No, question 4 is not it's not difficult. Look at this. It's just an equation. So just divide this 10 throughout. So you remain with tan theta is equal to 5. So now you press on your calculator, shift or second function, you go to tan, so it will bring tan inverse of 5. It will give you, I think, 72 or 78. I don't have a calculator here. I would have done it. So 70 something. Okay, try to punch for me. What are you guys getting for this one? When you punch on your calculator, tan inverse of 5, what are you getting? Somebody to punch for me if you've got a calculator, so that I can do clear explanation. What are you getting? Anybody here? What are you guys getting? Okay, 78. Yeah, I can see somebody that's commented 78. Yeah. So this is 78 point something degrees. Yeah, 78.7. So this is what we are getting, right? So for this one, it's only one solution, because the range here, it's ending at 90. So it's like this. We've got 0, 90 degrees, 180, 270. So it's falling in between this quadrant, the first quadrant. So it's only one solution, because we're ending at 90. But if they said up to 360, even this one could have been your solution from here. You would have gotten this 180 plus this. You get two solutions. That's how it was if it was more than 90. So that's the thing, guys. Thank you so much. Like internet has not performed. Thank you so much. And please, if you want to learn more with us, you can get in touch with us on this number. We offer online tuitions. And like you are, today there's a promotion that is going on. It's called Teachers Day promotion, where you're expected to only pay 100 kwacha and get added to two subjects of your choice. Remember, we do 200 kwacha per subject, but here we're just giving you to pay a 100 kwacha and get added to two subjects of the choice. This has been Sichamba Jacob. Gift, thank you so much. Who else am I giving a shout out? Edward, thank you so much. Maseko, thank you so much. Elena, thank you so much, Elena. Rita, thank you. Okay, Infinite. What's the name again? And nine. Infinite. Nicely done. Thank you so much. Thank you so much for coming through. Please keep on watching. I think time and time will be coming live like this to just share our knowledge with you. Hopefully, the internet won't be performing as it has been. Justin, thank you so much for that comment of yours. And bye bye.